Hey everyone, this is Derek, and in this video we're going to look at some application problems involving quadratic equations. So there's basically going to be kind of two styles, and with quadratics we have two things that we are generally looking for. So if I have some sort of parabola, there's these x-intercepts. Those are going to be the places where the function equals something. So like if you've set two equations equal to each other, got it equal to 0, this is what you're solving for. This is what the quadratic formula solves for. If you're looking to minimize or maximize something, minimize cost or maximize profit, those are going to happen at the vertex. So if the problem talks about wanting to find a minimum or a maximum, it's a vertex problem. If it's something where you're equating either like try to set a profit to 0, that's going to be, you're finding the places, you're finding these intercepts. If you're finding a spot where supply equals demand, again, two things equal to each other, that means you're finding intercepts. Mins and maxes is this one. So with that in mind, let's kind of look through these. So find the number of units to produce the maximum revenue, so it's a vertex problem, and then find the maximum revenue. So remember, our vertex is two coordinates. In general, this is going to be units, and this is going to be money. And it may be profit, it may be cost, it may be revenue, whatever, but we're generally going to be putting in, we made some number of things, and we're getting out some dollars. So the first one is find the X because we're looking for the units. The second one, the maximum revenue, will be find the dollars. That's the Y. So we're looking for the X and the Y of that maximum point right there. So to remember, for our vertex, we do X equals negative B over 2A. And this is written backwards, but our B is that negative 346 with the sign, and then 2 times 0.8. And it's going to be a double negative, so my result is positive. And I threw that in the calculator, and it comes out to 216.25. The directions here say round to the nearest tenth, so the computer answer for that would be 216.3. This next part is super important. Do not base the calculation on the rounded answer. Base your next calculation on that exact answer. So now we'll take this and plug it in here. So we're finding R of 216.25. The rounding reduces error, so we want to make sure we're using this one. So then I threw all that in my calculator, and I got 37,411.25. So careful not to use the rounded one. So for this one, the cost function for a certain company is that, the revenue function is that. Recall that profit is revenue minus cost. Set up a quadratic and find two values of X, the production level, that will create a profit of $200. So they're reminding us that profit equals revenue minus cost. So what I will set up is we want to have a profit of $200. Our revenue equation is right here. And then I'll take away cost, because revenue minus cost. So 50, oops, one more 0 in there. Cleaning that up a little bit, I'll have 200 over here for a moment. I'm going to write it in descending order, so we're going to have negative 0.5 x squared, and then 80 minus 50, so that would leave me 30x, and then minus that 200. And then bringing this 200 over, I will get 0 equals negative 0.5 x squared plus 30x minus 400. From here, you have the choice. You can just plug it in the quadratic formula just like it is. I did in the notes just to show you can. The other thing, if I were doing this just for me, I probably would make it easier, and I'd multiply both sides by -1 and make it positive, negative, positive. It's just one less negative sign to kind of keep track of in the problem. That said, both ways are fine, so I'll do it as the signs are. So let me get all this set up, and I'll cut back. Okay, so here's all that set up in the quadratic. So the sort of disadvantage of not doing it is you kind of end up with this weird little sign in the denominator, but I'll show you how to clean that up in just a second. So x gets you -30 plus or minus If you throw all that in the calculator, that comes out to 100 over 2, and then this is really negative a half, so or half of 2 is 1. So this is just over a negative 1. So then right here, I'm just going to go negative 1 into negative 30, and I'm just going to think of that as a positive 30, so I don't have to overthink these signs. And then plus minus would just be minus plus, which is the exact same thing. So plus minus, square root of 100 makes 10. So my two values are going to be 30 plus 100. So 30 plus 100 would equal 40. And then 30 sorry, I said 100. 30 plus 10 would be 40. 30 minus 10 would equal 20. In the notes, I drew a little picture of kind of what we were trying to find. So we started with we made this profit function, which had a negative coefficient, so it's parabola opening down. We set our profit level, which is our y, to 200, and then we were trying to figure out the two places on x that made that happen. And so when it was 20, that gave us an output of 200, and at 40, that gave us an output of 200. Okay, so this one is find the market equilibrium for the following. And so if we're given two equations and we're setting them equal, that's going to set up a quadratic that we're going to get to 0. So that's going to be either a factor or a quadratic formula problem. These two are set up perfectly, right? Because P equals this, P equals that. I can just set those two equal to each other and solve for Q. Because of my handwriting, I'm going to use capital Q. My Q's look so much like 9s. It makes it really hard to follow. And so here we have 289 minus 3Q. So I'm going to bring everything this way so I keep that positive Q squared. So here we'll have Q squared. Adding 3 on will give me 18Q. And then subtracting that over is going to give me 1215 equals 0. So this one is actually an example of this factors, and man, I wouldn't want to try to figure it out. So this is a great place to use the quadratic formula. So this time, instead of x equals, it'll be q equals negative 18, and then plus or minus 18 squared minus 4 times a times c. All over 2a. So, and I chunked all that into a calculator, and I got negative 18 plus or minus 5184 over 2. And then cleaning that up, we get negative 18 plus or minus 72 over 2. So this is a quantity, and if I solve both of these, actually I simplified a little bit first in my notes. I went to negative 9 plus or minus 36 just to make it a little bit easier to see the math. So you see I just divided both. So negative 9 minus 36 is a negative number, and we can't have a negative quantity. That doesn't make sense. So it's got to be the negative 9 plus 36. So that's going to make Q 27. And then to get P, all we're going to do is go back here to either of these equations. I went with a nice, easy one. And so then P, the price will be 289 minus 3 times Q 27. And that was 208. Okay, so for this last one, there's a couple of different ways to solve it, but there's one that's easiest. So let me show you that. So in the previous example, I couldn't eliminate the q squared because only one of the equations had the q squared. But here, notice I have p squared in both equations. So what I'm going to do is solve each of these for p squared and then set them equal and then dodge the quadratic part, and it'll be a little bit easier. You'll see it'll come back at the end though, but it'll make for a little easier math. So for this one, I'm just going to write this as p squared. I'm bringing this over to that side. So I'll be negative 3q plus 2673. And then for this one, I'm just going to bring p squared over to this side. So that's going to leave me 2457 plus 6q equals p squared. So if each of these things equals p squared, now I can set them to each other. So 3q plus 2673. Adding the 3q over to this side, I get 9q. And then subtracting this over, I got 216. and then dividing both sides by 9, that gave me Q equal to 24. And so now that I know my quantity, I can go back and solve for price. I went with probably that equation. Yes. So I did P squared equals negative 3 times 24 plus 2673. So P squared equals 2601. So generally when you root both sides of something, you need to do plus or minus because there's two solutions. In this case, we don't want a negative price, so we only have to worry about the positive root. And for this example, that comes out to be 51. So our Q and our P.